wondered what makes your computer tick? What's the secret sauce that lets you seamlessly switch between dozens of Chrome tabs while simultaneously editing videos and streaming your favorite tunes? Think of the CPU, or Central Processing Unit, as the brain of your computer. It processes instructions and performs calculations at incredible speeds. RAM, or Random Access Memory, is like your computer's short-term memory. It stores the data your computer is actively using, allowing for lightning-fast access. This means that the CPU can quickly retrieve the information it needs without having to wait. Now, think of your storage, like a hard drive or SSD, as your computer's long-term memory. It holds all your files, applications, and operating system. When you open a file or application, the data is transferred from storage to RAM, so the CPU can access it quickly. Together, the CPU, RAM, and storage work in harmony to ensure your computer runs smoothly and efficiently. Okay, imagine RAM as your computer's super-fast workbench. It holds all the tools and information your CPU needs to get the job done right now. When you open a program, its data gets loaded into RAM, so your CPU can access it instantly. Unlike your hard drive or SSD, which store data permanently, RAM is volatile. This means that when you shut down your computer, everything in RAM disappears. Tasks like video editing, gaming, and running multiple applications at once rely heavily on RAM for smooth performance. For example, having multiple browser tabs open at the same time uses a lot of RAM to keep everything running quickly. Now, let's explore the differences between RAM and long-term storage like hard drives and SSDs. Think of your hard drive or SSD as a massive warehouse, storing all your files, photos, and applications for the long term. RAM, in contrast, acts like the express lane at the warehouse, holding only the most critical items your computer needs immediately. While your hard drive or SSD offers ample storage but operates at a slower pace, RAM is smaller in capacity but significantly faster. Accessing data in RAM is akin to a Formula One race car, whereas retrieving it from your hard drive or SSD is more like a leisurely stroll. Use cases for RAM include running applications and multitasking, while hard drives and SSDs are ideal for storing large amounts of data over time. Just like there are different types of cards, there are different types of RAM, each evolving over time with its own strengths and weaknesses. It all started with DDR, then came DDR2, followed by DDR3, and now we have DDR4. Each generation brought improvements in speed and efficiency. DDR4, for instance, is much faster and more efficient than DDR3. Choosing the right RAM depends on your computer's motherboard and your specific needs. So, it's essential to do your homework before hitting that buy button. Ever tried juggling too many things at once? It's chaotic, right? Well, your computer feels the same way when it doesn't have enough RAM. The more RAM you have, the more programs and data your computer can juggle simultaneously without breaking a sweat. For instance, you might be editing a video, browsing the web, and streaming music all at the same time. If you're a hardcore multitasker, running multiple demanding programs at once, investing in ample RAM is crucial for a smooth and responsive experience. Remember those DDR generations we talked about? Well, each generation is like an upgrade in the RAM world, bringing faster speeds and improved efficiency. DDR4 is the current mainstream champion, but DDR5 is on the rise, offering a significant performance boost. For instance, DDR4 can handle speeds up to 3,200 MHz, while DDR5 can go beyond 4,800 MHz. Now, let's compare RAM to storage devices. An SSD can read data at speeds up to 550 MB/s, whereas a traditional HDD maxes out around 150 MB/s. NVMe SSDs, on the other hand, can reach speeds of up to 3,500 MB/s, making them the hypercars of the storage world. Clock speed and latency are like the horsepower and handling of your RAM. Clock speed, measured in MHz, determines how fast your RAM can process data. Latency, measured in nanoseconds, refers to the delay between requesting and receiving data. Lower latency and higher clock speeds translate to snappier performance. So when choosing RAM, Look for a balance between these two factors. For gaming, prioritize higher clock speeds to handle intensive graphics. For multitasking, a balance of speed and latency ensures smooth operation. On a budget, opt for RAM with decent speed and latency for efficient performance. Remember, the right RAM can significantly boost your system's overall performance. How do you know if your computer is craving more RAM? Well, if your system feels sluggish, programs take forever to load, or you're constantly hitting the dreaded not enough memory error, it might be time for an upgrade. Other telltale signs include stuttering during gaming, slow rendering times in video editing software, and excessive hard drive activity. To solve these issues, consider upgrading your RAM. Check your computer's specifications, purchase compatible RAM sticks, and follow a guide to install them properly. Gamers and video editors, listen up. RAM is your best friend. Games like Cyberpunk 2077 and software like Adobe Premiere Pro are RAM-hungry beasts, demanding vast amounts of memory to store textures, models, and video frames. By boosting your RAM, you can enjoy smoother gameplay, faster rendering times, and a more responsive editing experience. Trust me, it's a game changer. Before you go on a RAM shopping spree, there are a few steps to ensure compatibility. First, check your motherboard's documentation. Identify the types and speeds of RAM it supports. Next, use a RAM compatibility checker tool online. Enter your motherboard's model to get a list of compatible RAM. Finally, ensure the RAM you choose matches the specifications for a successful upgrade. Dual-channel memory is like having 2 lanes instead of 1, allowing data to flow more efficiently compared to single-channel memory. By installing 2 RAM modules instead of 1, you can effectively double the bandwidth, significantly boosting performance in memory-intensive tasks. Most modern motherboards support dual-channel memory, so take advantage of this feature if you're looking for a performance boost over single-channel configurations. Ever noticed how long it takes your computer to boot up? Or how slow it feels when switching between applications? RAM plays a crucial role in system responsiveness. With enough RAM, your computer can load programs and data faster, making everything feel snappier and more efficient. Think of RAM as the fuel that powers your computer's engine. The more fuel you have, the smoother and faster the ride. To optimize RAM usage, close unnecessary programs running in the background, manage startup programs, and consider upgrading your RAM if needed. This ensures your system remains snappy and efficient, providing a seamless computing experience. So, how much RAM do you actually need? Well, it depends on what you do with your computer. For basic tasks like web browsing and email, 8 GB is a good starting point. If you're an office worker using productivity software, 12 to 16 GB will ensure smooth performance. For demanding tasks like gaming, video editing, or running virtual machines, 16 GB or even 32 GB might be necessary. Professionals working on 3D rendering or large datasets might need 32 GB or more. Remember, RAM is like a good investment. It pays off in the long run by ensuring your computer can keep up with your needs. Mixing different brands or types of RAM in a single system is like trying to mix oil and water. It's not ideal. Ideally, you want to use identical RAM modules from the same manufacturer to ensure optimal compatibility and performance. While mixing RAM might work in some cases, it can lead to instability, compatibility issues, and even system crashes. To avoid these risks, always check your motherboard's RAM compatibility list and stick to matching RAM modules for a stable and reliable system. ECC RAM, or Error Correcting Code RAM, acts like a bodyguard for your data. It includes special circuitry that can detect and correct single-bit memory errors, preventing data corruption and system crashes. ECC RAM is crucial for servers and workstations where data integrity is paramount, such as in financial transaction processing, scientific computing, and medical data storage. However, it's generally not necessary for everyday home use. your operating system is like the conductor of an orchestra, managing how RAM is allocated and used. It ensures that each program gets the memory it needs, while also using a clever trick called virtual memory. Virtual memory allows your computer to use hard drive space as temporary RAM when physical RAM runs low, although it's much slower. Another technique is paging, where memory is divided into small blocks or pages. Efficient memory management can significantly affect performance, ensuring smooth multitasking and faster program execution. Poor memory management, on the other hand, can lead to slowdowns and system crashes, especially when running multiple applications. So there you have it, folks, a deep dive into the world of RAM. We've covered its basic function, different types, speeds, and compatibility considerations. RAM is a critical component that significantly impacts your computer's performance. Understanding RAM helps you make informed upgrade decisions, ensuring smooth and efficient system operation. Consider your specific needs and usage patterns when choosing the right RAM for your system. Upgrading your RAM can lead to better performance. Subscribe for more tech tips to maximize your computer's potential.